Hello. Hello. I am Dr. Basavaraj, Professor, Department of EC, Siddhartha Institute of Science and Technology. So now I'm going to explain about the subject electromagnetic theory in transmission line. In that, we are going to discuss about the Coulombs law. So first, we are going to understand before doing the Coulombs law, what is charge particles. Then we're going to discuss about the Coulombs law. So electrostatic fields. Electrostatic fields is nothing but electric fields due to charge at rest. So the organization of the parts of an atom has electrons orbiting a large central nucleus, neutrons and protons. If the atom is having equal number of electrons and protons, then we say it is a neutral. And if there is a deficiency of electron, it is called positive ion. If there is an excess of electron, we are going to call as a negative ion. So if there is an unbalanced number of protons compared to the electrons, then ion is called a charged particles. So now let us see here in the first diagram, we have 3 electrons and 3 protons, no charge. So in the second diagram, you have 2 electrons and 3 protons. It is a positive charge because it is one deficiency of electron. So positive charge are more here. Then 4 electrons and 3 protons. So it is a negative charge. So charge can be formed by friction. In this diagram, let us see the 2 materials. One is wool, another one is polythene. If these two they rub each other, then the charge is going to flow from one material to another material. So now at present, the wool and polythene are each uncharged. And let us see, once they rub wool on the polythene, some electrons move from the wool to the polythene. They are now more positive than negative on the wool. So now here on the wool material, more positive than the negative. Then now wool is charged positively. Wool is charged positively. Then now polythene now the more number of electrons than proton. So now polythene is charged negatively. The overall effect of these charged particles produces a force. So these charged particles, so once they become a charged particles, they can able to have the force between 2 charges. The electric charge is held on the surface of the material. It is referred to as static electricity. Here static means constant. The charge it will be at rest. So this type of charge cannot move throughout the material. Now if it is an insulator, cannot move the charges. So these charged particles can exert an electric force. Similar charges repel each other and opposite charges attract each other. So these static charge can be produced in 2 ways. One is by friction, another one is by induction. So these attractive forces which keep the electrons close to the nucleus can be easily overcome. The electrons have relatively no mass compared to the nucleus. Therefore, it is only ever the electrons which can be transferred throughout the material or from one material to another. So now we know what is charge particle. Now let us, we are going to discuss about the Coulomb's law. So Coulomb's law deals with the force of a point charge exerts on another point charge. If we keep a 2 point charges, then there is a force will be experienced on one on another. So here let us we consider the charges are generally measured in coulombs. The charge unit is a coulomb. So 1 coulomb equal to 6 into the 10 to the power of 18 electrons. So it states that the Coulomb's law states that force between 2 point charges Q1 and Q2 is along the line joining them directly proportional to the product Q1 and Q2 of the charges and is inversely proportional to the square of the distance between them. So let us see the force between 2 charges can be represented in equations form F equal to K Q1 Q2 by R square, where K is the proportionality constant and Q1 Q2 are the charges in coulombs. So R is the distance between Q1 and Q2 in meters. So now here F is measured in terms of newtons. The constant proportionality in free space is given by 1 by 4 pi epsilon naught. So epsilon naught value is constant, that is the permittivity of the free space is given by 8.854 into 10 to the power of minus 12 farad per meter. If you substitute this epsilon naught value in the above K equation, we can able to find the K value, that is 9 into 10 to the power of 9 meter per farad. So now equation 1 becomes, we have substituted the K values for free space, that is Q1 Q2 by 4 pi epsilon naught R square. So here if the point charges Q1 and Q2 are located at the points having position vector R1 R2, then force F12 on Q2 due to Q1 is given by, see here force is a vector quantity. It is having both magnitude and direction. So in the first we discussed only magnitude. Let us, we have to add the direction also, because the force is a vector. Now let us see with magnitude and direction. So here the Q1, Q2 are placed and these are at a vector distance from the origin. Q1 is R1 and Q2 is from the origin is R2. So R12, this vector distance can be calculated R2 minus R1. Then the magnitude part will be represented by the R12, the 2 double slash will give the only magnitude. So the direction vector is given by R12 vector divided by the magnitude. So here the already R square, that is magnitude, is there, and this another one magnitude, it become R cube in the denominator. So F12 force on Q2 due to Q1 is given by Q1 Q2 by 4 pi epsilon naught R square and R12. So this R12 can be calculated R2 minus R1. Similarly, the magnitude will be R2 minus R1. The coefficient squares if we take, we can able to get the magnitude. So force F21, that is force on Q1 due to Q2 is given by F21, that is F12 and the direction R21. Here there is only the opposite side. So that is the reason we are going to represent the negative AR12. So F21 equal to minus F12. That is the direction vector AR12, R21 equal to minus AR12. So whatever we discussed till now, it is for 2 point charges. Now, if you have more than 2 point charges, that can be calculated with the help of principle of superposition. So principle of superposition states that if there are n charges Q1, Q2, dash Q1 located respectively at points with position vectors R1, R2, dash R1, the resultant force F and charge Q located at point R is the vector sum of the forces exerted on Q1 due to Q1, Q2 dash Q1. Hence, it can be written the force, total force equal to the total force equal to the force due to Q1 charge can be written like this. Q1 R minus R1 divided by 4 pi epsilon naught. R minus R1 magnitude Q. Similarly, for Q2 dash Q1. The total, the electric force due to more than one charges on Q can be given by Q by 4 pi epsilon naught. Summation of here K equal to 1 to N Q K R minus R K divided by R minus R K modulus Q. So with this, it completes the Coulomb's law.